All right, we left off, we talked about name constants, okay? All right. The next thing is arithmetic operators. This is math, okay? Remember the whole plus sign we've already talked about at the beginning of the chapter? What was it used for anyway?
Addition.
No, before that. What we used at the beginning of the chapter? What was it?
Concatenation.
It was used for string concatenation. Remember we had two strings, we want to put them together? We used the plus operator. Well, it can also be used for math. So, I mean, it's not like we totally took out the math component, but it can be used for math. You can also, you know, we have addition, subtraction, division. We have all that normal stuff. But these three, addition, subtraction, and multiplication, work as normal. Nothing new there. Nothing's changed. Now, division is a little bit different, okay? It depends on how it's being used, whether it's integers or floating point, all that kind of stuff. And we're going to talk about that, okay? It says when it performs division on floating point, it performs calculator division. In other words, with floating point numbers, in other words, one with decimal points, it'll do regular division like a calculator. Okay, no big deal. All right? So 7.0 divided by 2.0 will print 3.5. Just like a calculator would give you. Nothing different there at all. Okay? But, okay, there's the same one we just saw. Okay. But integer division, okay? The next line has to turn 5 divided by, actually it'll be the same. Yeah, it's the same thing. Okay, hold on. It always goes to the largest one. Okay. It says 5 point, you see how 5 is an integer and 4 points a floating point? So it's different. So as an example of a mixed expression is the equivalent of it. Double is bigger. So double, should say that in here. Dava temporarily promotes the less complex. Okay, so I was right. What happens when you have a mixed variety, so an integer and a double, it converts the integer to a double and then performs like regular, okay? But if I have two integers on the other hand, it doesn't do that, okay? Which we're going to see in a second. But they both stay integers. We're going to see what that does in a second. So a 5 and a 4 period, you know, 4 point, like 4.0, it converts the 5 to floating point just like the 7.0. Then it does regular calculator division. Okay, so it promotes it to the bigger data type. All right, now, here's this one. What is 7 divided by 2?
3.
What do you think Java gives us? You know what, let's look. Let's find out. Let's see what it does in Java so we can actually do it here. Let me bring my program up again. So it's 7 divided by 2. I want to make sure I give you guys plenty of examples. So no one can, I don't understand. What was it, 7 and a 2? Is that what it was? So what do we think we're going to get? Someone say 3.5?
I say 3.
Okay. Why do I have an error?
One error.
Oh, hold on. Forgot to get rid of that stuff. All right. Okay. 7 divided by 2. Now I'm going to bring up my buddy here, calculator, and I'm going to do 7 divided by 2. How come I'm getting a different value? One gave me 3.5, one gave me a 3.
Because you're using int instead of...
I'm using integers. Integers have no decimal places. So
calculators already use
right.
doubles.
Right.
Correct? I mean,
correct, yes. If I use doubles, it'll do a calculator division.
Yeah.
But if I don't, it's going to do integer division, and it truncates it.
It just drops it off.
Just drops it off, exactly. Okay. Now, the next one is talking about, well, if I could, what the heck? What's going on? I can't. I'm locked up. Oh, there it goes. It's back. That was crazy. All right. What about this guy? All right. It's modulus. They talked about it here a little bit. The operator is called modulus. Performs grade school division and generates only the remainder now. So when I run this, 7 modulus 2, what do I get?
0.5. 5.
What's the remainder? I get 1.
Okay.
What's the remainder? Remember when you did this? You did 7 and a 2, and then so on and so forth. And the way you remember this, just so you know, you take the 2 outside. So if you were, well, okay, let me try to draw it. Let me draw it on here. It's not going to look very pretty, but okay. So for this top guy right here, okay, you take the 2 and you put it in the front. So you get 2 up here, and then this. Remember that from grade school?
It's
So,
in the doghouse.
so it's basically 2 and a 7.
Gotcha.
Okay? So how many times 2 go into 7?
3.
3. So we're going to put a 3 up here. 3 times 2 is 6, so we're going to subtract 6. And we get a 1. Remember we always did this remainder of 1. Ever remember that? So modulus returns the remainder. That's why we get a 1. So what's this guy return?
Let's see.
Oh. 8 and 12. So,
4, yeah.
actually, we didn't check the other one to make sure we were right. Hold on. All right, let's check this one. Make sure we got a 1. We got a 1. Very nice.
Okay.
Very nice. All right. Now, what is the other one? 8 and 12? So what do we get? Do we get a 4 or do we get 8?
4, so it's 4.
Do we get 4 or do we get 8? Let's look at it. All right. Remember what I did here? So I can take the 12 and put it in the front. Okay? So I'm going to do 12,
Wait. Oh, okay.
8. How many times 12 goes into 8?
0.
0. What's my remainder? 8.
Let's do that.
Okay? See that? See, it's so tricky because sometimes you look at that and, oh, it's 4. No, it's not. If you can remember, the component on the right goes in the front. That's the only way I can ever remember it. Because like the 7 and the 2, I got that one easy. But the 8 and the 12, when they're the opposite way, you just assume the small into the big.
This might seem like a silly question, but why would you need the modulus operator? Like,
All right.
can you give an example of why
yes.
you would want it? Or
Okay, if I want to find out a number is an even number or not, I can do modulus 2. If it returns a 0, see, okay, well, let me show you that. That's a very good question. Let's do that. Let's see. This one should return an 8. Is that what we determined?
Yes.
Okay,
Yeah.
an 8. We got an 8. Okay, everybody see that? All right, so we want to see a good use for this. I want to figure out if 9 is an even number.
Okay.
Okay, that's all I want to figure out. So I'm going to do modulus 2. Okay, does 2 go into 9 evenly? No, I get a 1. So what I could actually do here, let me write this a different way. We'll put an if statement here. If 9 mod 2 is equal to 1, print odd. Else okay. Make sure we do it. All right. So now let's see. So we already know the answer is even. So wait a minute. Sorry.
No.
If it's 1, it's okay. There we go. All right. Oh wait. No, that's wrong. It was odd. I had it right at the beginning. My fault. I was dreaming there. All right. So if the results of 9, if this number, mod 2, is 1, then it's an odd number. Do you agree with that?
True.
All right, so if I run this, I get an odd number. Because the results of 9 and 2 was equal to 1. So let's try a different number. Let's try 6. I mean, we know the answer, but, just say we didn't know. Even. See that?
That could be like figuring out prime numbers.
I could figure out
Exactly
prime
what I
number.
was just- I couldn't think of the word.
Here's a perfect example. When I was in the Air Force, I wrote a program called Leaves that I think I might have told you about that was used to calculate when people are on leaves. There's a weird deal. I don't remember exactly how it worked now, but if you went on vacation on a Sunday, your vacation started on Sunday. But if you went on vacation on a Saturday, you only got charged for 1 day for the weekend. This is where the military, you're pretty much on duty 24/7. So I don't remember the exact particulars, but there was a special way for that. But I always had to figure out what the day of the week was. So I could always do modulus 7 to determine if it was divisible by 7. That told me if it was the Sunday or not. So that's why I did it, and it solves it. Some of you, is anyone in computer security yet? No. Well, when you get there, you'll have to do something with the Caesar cipher. You'll have to determine if you need to wrap at the end of the alphabet, and you can do modulus 26 to determine, if you've gone over the alphabet or not. So just remember modulus. It comes in very handy. It's also used massively in encryption. We use it in almost every single encryption protocol. But we just very easily figured out if it's even or odd with that. I could enter a number, and if it's an even number, say even. If it's an odd number, say odd. I could figure out if it's divisible by 3. Okay, let's do that. I want to find out if a number is divisible by 3.
You add them up.
No, I don't want to add them up.
You add up the digits to see if it's divisible by 3.
No, I don't want to do that. I want to use modulus for that. It's more fun.
Okay.
All right.
Play along.
We'll have a yes and a no. So if I have a number like 6, is 6 divisible by 3?
Absolutely.
So if I put the 3 in the front, I'm going to get a remainder of what?
0.
0. So if it is equal to 0, then it is divisible by 3. If it's not equal to 0, I'm going to get no. Okay? So let's run this one. So we should get a yes because this is 6. Yes. Okay, let's put in 65. Is that divisible by 3? No, it's not. Yeah, I could put in 6. I could put in some huge crazy number here.
Yes.
Let's test it. Let's test it. Let's bring up handy dandy calculator. 655 87 no 8 4 7 5 9 divided by 3. Now if it's divisible by 3, it's going to say, oh, we got a remainder. It's not divisible by 3.
Unevenly.
Threw me off.
Yeah, yes, it did me too. I thought it was originally.
Actually, I should have looked at the last 2 numbers.
So, you kind of understand a use for modulus now. I want to know if a number is divisible by 42. Now we'll say 43. Very easily. Nope, it's not.
Surprise.
Yeah, amazing, huh? But, I mean, that's just an easy use for it. Okay?
No, I appreciate that.
Get that? All right. All right. I don't think I did that last year, so that was a good question. All right. Look at that math, that art.
I was wondering if someone else was going to come in here and just see that and just wonder what class we're in. See, 2 goes into 7, 3, the remainder.
Exactly. All right. All right. So we're done with modulus division. Modulus is so crazy important. You'll use it later on. All right. So let's figure out these things. So I got some variables there. I got A is 5, B is 2, C is 3.0. Okay? Got 2 integers and a double. Now we're going to use the operator precedence table. Anyone remember that whole order of operation thing?
Yes.
What happens first?
Parentheses.
Parentheses. So we're going to do the stuff inside there first. Okay. C is what? 3.0.
3.0.
Now, we got a problem. We got a plus and a division. Which one's first?
It goes to the
Plus.
no, to the plus.
Division comes
Oh,
first.
right, multiple.
Multiplication, division first. So we're going to have to divide the A and the B. So A, 5 divided by 2 is what?
As an integer, it's going to be 2.
It's an integer.
It's different though in Java.
No. No, 5 is an integer up here. Let me get my thing back. 5 up here is an integer. I mean, A is an integer and B is an integer. So forget the C.
You're saying 3.0 plus 5 halves.
No, forget that. Remember, this is first.
2.2.
No. This has to go first.
Okay.
And we're doing integer division. Just like we did on, where was that? This slide here, remember this guy? Remember we returned and the result was 3. Remember, not 3.5, it was just 3?
Correct.
All right. So we're going to do
Oh, okay.
5 divided by 2 gives us what?
2.
Oh, darn it. That one's too tough. Let's figure it out. 5 divided by 2.
Oh, yeah, it's 2.
It's 2.
Because he said it was like, I don't know.
And it's 5 divided by 2? Okay. Let's make sure. Yeah.
Exactly.
All right.
Two, yeah.
So it's 2. All right. All right. Now, the 7 divided by 2 is the 3 ones. Okay, so the A divided by B is 2. We know that. So we have C plus 2. You all agree this is 2 now? So if I was to get on my awesome marker here, now this is all a 2. Okay? Then we have 3.0. So what's my answer on the left side? 5.0. You like that, huh? All right.
Cooking with fire now.
All right. Now what's this divided and a multiplicated? Which one do we do first?
I would do the multiplication.
Oh, that's
Left to
where I
right.
messed up.
Left to right. We got to do the division next.
That's right, so that would be
Divided by 10. What do we get? Now, wait a minute. This is a double. This is an integer. What do we do?
0.
This would be 0.
So we need to put a 10 divided by 0 on it. Because remember, whenever you have one that's a double, it converts the other one to the larger data type. So now 10.0 is a 0. I mean, is a double as well.
Oh,
So they're
okay.
both
So it's
doubles
not a
now.
0.
So what's 5 divided by 10?
Now it's 1/2.
How about 0.5? Is it 0.5?
Yes.
Am I dreaming?
No.
All right, 0.5 is the answer. Okay?
Correct.
All right. And then times 5. So we got a double
2.5.
multiplied by 5. So it converts this other 5 to a double as well.
Correct.
So what do we get now?
2.5.
2.5. We think so? All right. Let's check it. Phew, that's a lot of work. All right. I'm going to copy this stuff in there. We're going to try this baby. Make sure we're on the right track here. Make sure Terry's not really messing us up. All right. So we're thinking 2.5. So I'm going to put that right in here. It should work, shouldn't it? Oops, somehow I got an extra. That all looks good now. All right. Do I? No. No, I got 2 there because I got 1 here and 1 there. Okay. So we want 2.5. Yes! Look at that, 2.5.
Awesome.
So we were correct. All right, let's do the next one. Uh-oh. 0 modulus A. So what happens now?
What's a 0?
A is 5. So the 5 goes in front of the 0. So how many times does 5 go into 0?
0.
0. What's the remainder?
0.
0. So this one's 0.
Create a black hole by doing that.
But unless you check yours.
Yes. Exactly. Now, all right. Now over here we got 0 divided by A. 0 divided by 5 we get. What happens? Now 0 is an integer.
Okay. Okay.
5 is an integer. So what do we
It's
get?
going to remain an integer, so it's going to be 0. 0 divided by 5.
Okay.
0.
All right. So we got 0 plus.
3.5 or 3.0.
So I got 2 pluses here. The answer is what?
3.0.
3.0.
0.
All right. Let's test it out. Make sure we're not a bunch of idiots. All right, here we go. Get ready for it. Wait for it. Yes, we were right again. We're on a ball. We're on a roll here. 3.0. All right, so everybody know how to do that now?
Yes, sir.
Parentheses first. It was funny. I was in went to a programming class about Remedy. Anyone ever heard of Remedy? It's a help desk program, big time. Yeah, man, writing code for that, it throws in like 1,000,000 parentheses. Like, let me show you an example of what it would do. Like, you'd write nice code like this, and you would end up with this. This is what it would convert it to. You would have one around this. Then we'd have another one around this whole thing. Then it would have one around the C. I mean, it was like crazy. You end up with like 16 parentheses anytime you do any type of thing like this. Because it would, the whole point is it want to really make sure what it's doing. It does everything by the order of the parentheses, from the internal parentheses out. And it was like, what the heck? It was crazy.
I got a question.
Sure.
Just a random question. How many viable programs do you figure that there are out there? that, I mean, just like besides, you know what I'm saying? Like, you just mentioned one, you mentioned three
Right.
alone that I've never heard
Right.
of.
Okay. Oh, there is millions and millions of programs out there. Yeah. It's just, there's more every day. You know, I wrote many programs myself, you know.
Well, I mean, languages.
Oh, languages, there's a language called B-E. It's B-E-E, I think. I mean, it's just B-E. But, I mean, there's tons of them. There's,
I was curious.
you know, when I went through my computer science degree, I took Pascal, Fortran, COBOL, Assembly, and C. I took 5 separate languages. But, you know, that was just to get my bachelor's. And now, you know, I've taken dozens since then. You know, Java wasn't even made then. It's kind of funny because, you know, I teach Java for Park University, and I was one of the first Java teachers they approved. But I had to prove that I could teach Java even though there was no classes in Java. So I couldn't really tell them I took a class in Java because there was none, because I was going to be the first class. So I basically had to prove them, you know, hey, I know C, I know C++, and it's similar. But yeah, a lot of languages are similar. Like C Sharp. C Sharp, what they did that with that language, they took the good parts of Java, the good parts of C++, and the good parts of Visual Basic, put all together into C Sharp. So it works great. There's all kinds of cool stuff.
So C Sharp's probably one of your better languages.
Yeah, it's one of the newer ones. It's very popular too. But it's not as portable as Java. And you know, when you get into like the security field, Java's kind of important. Like Android development, it's all Java based pretty much. Not totally, but you know, a lot of it is. So, all right, let's continue. I absolutely love this. Increment and decrement. Okay. Okay. Does anyone know what type of operator these are? They're actually unary operators. They take one argument. Okay? So increment and decrement. It's plus plus and minus minus. So here we go. We got x plus plus right there. That's the equivalent statement. This 3 underscore or 3 lines means equivalent. So x plus plus is equivalent to x is equal to x plus 1.
So doing counters and stuff,
Yes.
it's a quick way to do counters.
X minus minus is equivalent to x equals x minus 1. All right. It says proper style dictates using this stuff here on the left. Okay? Don't use the stuff on the right. Why? Anyone? It sounds cool. Looks
No, I
cool.
said old school.
Oh,
It's-
yeah. I mean, it's
Saving
shorter.
space.
You know, if I'm going to be writing a lot of code,
It sounds cool.
I'm saving some space here. Okay?
It's
Now,
obsolete.
let's. They don't cover something here. This is kind of important. Okay, so luckily for you, I'm going to cover it now. All right, I'm going. You know, I got my print statement. I'm going to get rid of a few dozen brackets here. Okay, so what if I want to print out a plus plus? Okay, what am I going to get?
6.
All right, we got 1 vote for a 6. What the?
I would have guessed 6 too.
I was going to guess 5.
I thought x plus plus is the exact equivalent of x is equal to x plus 1. So if x is 5, then x is equal to 6. Is that right?
Yeah.
All right, let's just make sure we're not dreaming. Let's change it back to the original way. A is equal to a plus 1. Okay, let's do that one. I don't know if yeah, okay. So I do get 6. So it is 6, but then how come if this is the equivalent statement, am I getting 5?
There's an error somewhere.
No, there's not.
You're doing it wrong.
No, I did it exactly like I wanted to.
Like if you're in a loop, you'd have to get to the bottom of the loop and then go back to the top before it would
Does
actually
it have
do
to
the
start with
operation.
1? Is that the issue?
No, but he's kind of on the right track. Okay, you ever heard of something called prefix, postfix? This is a postfix operator, which means when you get to this statement, perform this statement and then add a number.
Oh.
Okay, so let me show you what I mean by that. Okay, so I'm going to print out A, then I'm going to add and print out A again. So we should get 5, and we would think 6, 6. But what's happening is we get 5, 5, 6 because the first one prints 5. And this is a postfix, which means after the fact, add to it. So the statement says print the A, then add the number.
So you would need at least those last two statements? You wouldn't need the first statement.
If I want to get 6 and do it something like this, I would have to use it, these two.
Right.
I wouldn't need the first one. But there's a way around that. I can convert it to a prefix statement.
Plot thickens.
Now we get 6. Very seldom ever makes a difference.
What does if you're trying
Until it
to,
does.
But it really depends. I mean, if you're doing a loop, x plus plus is fine all day long. But if you are, printing something, then you want to increment. I'll just show you that because if you ever use it, and you'll be like, what the heck? Like you guys said, we're going to get 6. No, we're not. We're going to get 5. Why are we getting 5? Well, because it's a postfix operator. Yes.
Is there a way to control the increment amount other than 1?
Yes, there is. Now I'm going to print A plus equals 2, which is 7. Now this one, there's no prefix postfix. So now what I did was I said A is equal to A plus 2. What am I going to get now?
13.
Should get 13. 13.
What do you mean there's no prefix postfix now?
I mean, I don't need to put it before the A to make it do it first.
So it's only the initial.
It's only the unary operators of plus plus and minus minus. The problem is I use plus plus all the time with loops. Like all the time. Okay? When we get into loops, I'll show you that again so you remember it. But yeah, this is, can't think of the name of it all of a sudden. Compound operator. There it is, compound operator. Very important. We can also do things like minus equals 1, or that will be 4. Okay. Y'all can see the results, can't you? Okay. Or I can do minus equals 2. That'll give us a 3. I can do times equals 2. I'm going to get 10. Everybody see that? Kind of handy. All right. All right. And that's on the next slide anyway. But all right. So, again, it really doesn't mention in the book, but just remember these are postfix operators. Okay. All right. Now, there's also compound assignment. Ah, look at that. There's the answer to our question. Plus equals, minus equals, multiply equals, divide equals, modulus equals. Same way. X is equal to x plus 3 is x plus equals, it's the same as x is equal to x. X plus equals 3 is the same as x is equal to x plus 3. Whew. Okay? It's just an easy way of writing it. And I'll tell you, it's weird the first time you start doing it. But once you start doing it, it's like, it's kind of like, I got a student, John Spencer. He's gone now, but every time he turned in something to me, I had to get a dictionary out because he always used these words I have no clue what he's talking about. But he does it so often, they're natural to him. You ever read something, it's like, what? Well, it's the same thing here. Once you start using something, get used to it, you're just going to be second nature to it. You just didn't know what it was. That's all. So, compound operators are amazing. Absolutely love them. All right. So what's this one do? Well, they want us to trace this one again. I'm not going to give you the assignment to do on tracing, but you already did assignment 2. Assignment 3 used to be tracing, but it was too easy, so I've changed it. It's much better now. Okay, so now we've already covered tracing. I'm not going to cover it again. Sorry, I just want to move on. So I might want to finish this today so you can do homework for Monday. Nice. Okay. Typecasting. Typecasting is another very important thing. Well, basically this whole chapter is important. Sometimes you need to convert a value to a different data type. Okay? Maybe I have a double and I want it to be an integer. Maybe I have an integer, I want it to be a double. Maybe I have a string, I want it to be a character. Or an integer, I want it to be a character. All that kind of stuff. So typecasting does that for us. Down here at the bottom, okay? So suppose you got a variable named interest. Right here, interest. That stores the bank account interest as a double. It makes sense, because I could earn cents. Like this month I earned 72 cents. I was like, great. Big bucks. All right, so stores my interest as a double. I want to extract just the dollar portion of it. Okay. So let's see what that looks like here. So we're going to get rid of some of this. So I want to see the integer of C. Okay, I'm going to get rid of these guys. C is now 3.6. Okay, what I'm telling it is I want to print out C. But since C is a double, I want to see the integer of C, so I should get just 3. Are you okay with that? There you go, I got 3. What if I want to do the other way around? What if I want to say double A? Now I'm converting A to a double. Easy enough. Okay? All right. So say it throws as double. You'd like to extract it. So we can basically say integer of interest. Remember, interest was a double. So we're going to get the result stored in interest in dollars. So that 3.6 is now just 3. Okay? Easy enough. All right. Says if you need to cast more than just a single value, you need to cast an expression, then make sure you put parentheses. So here, okay, we got a double and a double. And multiply them together, what are we going to get? A double. I want to convert the whole thing to an integer. So I put integer in front of it. So put it in parentheses. Now, the reason this one's kind of important is, couldn't I have just converted balance to an integer and interest rate to an integer and multiplied them?
Well, it'd be inaccurate then.
Right, because the answer would be an integer. I wouldn't have any decimal points in it. And I might have lost some money.
Exactly.
So what I want to do is do the multiplication with the doubles and then convert it to an integer.
Gotcha.
So hopefully I'll get that. All right, care or char. Is it char or care? Does anyone know?
Char, but I could see care.
I think I always call it care, but it's either one. Okay. A character, the reason I call it care is it's called a character. It's not a character.
I like the word char.
Yeah, so it's, I don't know. All right. So, but also we have charcoal. So,
That totally applies to this. Yeah.
exactly. So, all right. So, a character holds a single value. A character constant is surrounded by single quotes, and you see them right here. We have single quotes. All right. Just little baby quotes. Just one. Okay. So here's an example. We have a character of first, middle, and last. First is J, middle is S, last is Dean. Everybody know who those initials are?
Guy that wrote the book.
Exactly, John Dean. Yes, very good. All right. So they're all characters. Hey, all my examples end up with Ken Dewey in them. So in KD and
JSD,
all that
Jimmy
stuff.
Dean.
Yeah. So all right. So now we're going to say hello plus first plus middle plus last plus exclamation point. Well, let's look at what that does. All right, this is a string. Do y'all agree it's a string because of these guys right here? Y'all see that? It's a string. Okay. So now I'm going to add something to it. Or am I really adding something to it? What am I doing with this?
Just adding the letters to the first initial.
Right, I'm not adding them, I'm concatenating them to it. So I'm concatenating the first initial to hello, and then the middle, and then the last. So it's going to print, first, is it going to have a space in between?
Yes. In between the
After hello, it'll be just JSD
right.
Let's
It
see.
won't be spaces in
Hold on,
between.
we're going to find out. We got to know. Inquiring minds want to know.
Couldn't just run it.
It was on the PowerPoint. I had to copy it into my Java code. I can run it now. In case I want that again. All right. Let's compile it.
I love how you can do that. You can just totally.
Hello, JSD.
Oh, JSD.
All right. So what happened was we took the string hello and a space right here. Hello, comma, space. Right there. Then we concatenated first. First is the J, so we put the J. Then we concatenated again the middle initial S and then the D. And then we also concatenated the explanation point. Everybody see how we got that? Isn't that handy dandy? I know you love it. All right, that's what it prints. All right, escape sequences. You need these for your next assignment. Very, 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 very important. All right, show you what they do. All right. What if I want to print, we'll say, I want to make these tabbed apart. Okay. What I could actually do, I could put a tab character. What I did here, actually I think I could do that with single quotes as well. Not positive though. Yeah, I can. Okay. So, I said hello. I'm going to get rid of the spaces. So it's hello with no spaces. Okay. No comma, no spaces. Then first, now, so what's it going to print?
Hello, tab, JSD.
Hello, tab, JSD. Okay.
Tab's kind of big there, so I don't know.
Well, it's 5 characters. Should be 5. 3 characters. It's 3.
That's unnatural.
All right, well, sorry. So I could do the same thing over here. I can tab this guy as well. Now it's going to be hello J, tab, tab J, tab S, D. Are we okay with tab? Everybody see that?
Put a bigger space.
Oh, you know what? That's a good point. Thank you for pointing that out. It tabs to the next tab stop, which is every 5.
Oh, depending on where the hello
Right.
ends.
So 1, 2, 3, 4, 5, 6, 7, 8, 9. Or is it 9? It goes to the next tab stop, whatever that happens to be. I think I changed my font so it's not quite the right size on this.
Probably only going on the first J, you're only going to the first tab stop, it looks like, and then you're going to the second tab.
Right.
Yeah.
And then, so the D, if I put that again before the D here, I should get about the same size tab. Yeah. Between J and S and D are the same. So whatever that spacing is, that's how big a tab stop is. Now we have answered the question. All right. So there's tab. We could also do new line. Let's do that one. All right. I want a new line between each one of these. I want it to be hello on one line, the J on another line, the whatever, the S and the last all on one, whatever. So on separate lines. So what it did was it printed hello. Then it did a new line. In other words, the carriage returns, like hitting enter on the keyboard. Then I printed the first initial, which was J, another carriage return. Middle initial, another carriage return, so on and so forth. Now, I can include these inside of another string if I don't screw it up. Okay? I think I showed you a little bit of that last time. But you can put them inside a string. It's going to do the same thing. Like, say I wanted to tab hello out. I could do /t, 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 /t. I know it looks weird, but it's going to be hello tabbed apart. So you can put them inside of strings. What if I want to print a backslash? Obviously I can't. Because the backslash is an escape character. But if I put 2 backslashes, now I'm going to have H/E. But see that? See what that did?
Don't you need to have 3 right there?
Just 2. See, that's an escape sequence. So what I'm telling you is, hey, the next character is what the escape sequence is for. So if I give it another backslash, it says, oh, you really want to print a backslash now.
Oh.
So 2 backslashes will print 1 backslash. All right? Tab, we did new line tab. We can print a double quote. We can print similar. Let's try it without that. I want to print out hello quotes. Let me get rid of some of this garbage in here. I want the output. Here's what I want the output to say. And I want the output to actually be hello with quotes around it. You ever quote somebody, you put quotes around it? So I want my output to be that. So I'm going to say, okay, I'm going to put a quote in front of hello and a quote behind hello. Makes sense, but it ain't going to work.
No.
Ain't going to work. Doesn't like it. There's an error. So what we need to tell it is, oh, this isn't a quote, it's a quote. I mean, it's not a quote surrounding a string. It's a literal quote to print on the screen. See how the color changed? See? Now it's a string. So now it'll print hello with quotes.
Okay, why wouldn't you put the, can you go back to the string? Why wouldn't you put the backslash in between
Yeah, the
the
last
two,
quote.
the two double quotes?
Yeah.
Because,
It has to go.
Because the
in front
final
of the
quote
quotes
ends the
to
string.
quote.
yeah, the final one surround
Oh, okay.
the string surrounds the quotes surround the string, and oops, now I lost one. So that's the quote surrounding my string.
Okay.
This basically says print a quote. All right?
Because if you take the final quote off and try to compile it, you'll get an error.
Yeah, it's not. It's not even green anymore. It's gonna be like, can't do it. So now we have to put the final quotes back in there, and it fixed it. All right. All right. Oh, we can also do a single quote. Same thing. It's just single quote. Okay, but what about? Let me get rid of these double quotes. What's that going to print? So I put a /B between H and E.
Backspace.
Exactly.
Does it?
Yep.
Why?
I don't understand the purpose
Yeah,
of that.
why on earth would you need that, but okay.
Imagine the old dot matrix printers. You want to overstrike something.
Okay.
You would print the word out and you'd backspace and print another word on top of it. So what this would do is actually did print the H. Then it backspaced over and printed the E on top of it. If you saw it on a printout, you would see it that way. But we're seeing it on a screen, so you're not going to see it.
Oh.
But if you printed this, it would be an H with an E on top of it. Because a lot of things, changes you make, you got to overstrike and stuff like that. So, yeah.
Strange.
Yeah, it's backspace. He's right. All right. Yeah, it's not in the book. Is it? Anyone see it? No. Yeah, it's just one of those things. So, but again, the book can only cover so much stuff. All right. So there's an example of tabbing. We already did that. Why is it called escape sequences? Because it kind of stops what it's doing and says, "Whoa, I got something special happening here," and then it does it. So,
It just is.
yep. All right. I want to check something real fast. All right. So, primitive versus reference. Okay. It says there are two basic types, primitive and reference. Okay. Primitives are the basic type. Integer, long, float, double character. The ones that come with Java. Okay. Nothing special. It's just a number. It's just a character. It's just a whatever. No added functionality. Okay. So a primitive holds one thing, just the data. Now, if you were looking at memory in a computer and you said, I'm putting an integer, it'll just stick the integer in the hole. Okay? References are more complex. Those can be strings, counters, cars, whatever. I mean, it could be anything you want. They could have other functionality with them. Okay? Reference variables always start with the lower uppercase and primitives start with the lowercase. Okay? I said that right, didn't I? Primitives are lower and references are upper. Okay, all right. So remember, primitives hold one piece of data. Reference variables are specialty cases. Now it could be a string. Down here, it could be a string. It could be a calendar. It could be a car. It could be a whatever you write. Okay, they're declared with a reference type, and here's some examples. All right, and we're going to look more into that. Okay, but all right. Here's some basic string stuff. Again, we'll play with primitive and reference more later. But let's look at this string first, okay? Your assignment 3, at least for the guys in this room, is rows here, is string manipulation, okay? So what does this do, okay? So we got a string. Actually, let me copy this out into TextPad, if I can get to that page. Copy this out. Okay, let's dump all this, and we're going to go to here. All right. So, I got a string. So let's see what this does. This first line declares a string. Y'all agree with that? Okay. Declares a string. What's this second line doing? What's this part doing?
It's adding on to this.
It's kind of like another declaration.
Initializing.
The same.
The first part is declaring another string, but this one we're actually assigning it a value. So this guy we said,
Whereas the first
I want a
one-
string, it's going to be over there. Haven't built it yet. We have some space allocated in memory for it, but we haven't put anything in it yet. This guy here says, okay, we're going to declare it. We're going to have a string. It's going to be called S2, and its value is this. Okay. Now we say S1 equals goodbye. So now S1 has a value. So S2 is and I say hello. S1 is goodbye. Now we're saying S1 is equal to you say space plus S1. And what's S1?
blank.
Goodbye. S1 is goodbye. So what it did was said S1 is equal to this string plus what S1 was equal to, which was goodbye. So S1 is now you say space goodbye. Ever see that? It said S1 plus equals comma plus S2 plus period. What's this stuff do for me again? This is the same thing as saying S1 is equal to S1 plus. Okay, I could write it just like this. Yeah, I could S1 is equal to S1. Yeah, that's correct. Same thing. Okay, but it's short if I just do this. Say like 5 strokes there. All right. So what's my final output of S1? So if S1 at this point said, you say goodbye,
And I say hello.
so then S1 becomes comma space, or S1, so it was you say goodbye, comma space, and I say hello, period. So S1 is now equal to
You say goodbye.
you say goodbye and I say hello.
But you can't just say it, you have to sing it, right?
You say goodbye and I say hello. All right? Ever see that? All right. Something else I want to show you. I think it's covered in here, but I'm going to cover it right now anyway, just in case it's not covered. I want to make an integer. Actually, a string. No, a character. No, a string. Now we'll do a character. All right.
The string is basically like the kind of
A string is a reference type. It's a bunch of characters.
characters or numbers, isn't it?
Yeah. Oh, yeah. Yeah, it could be letters or numbers. Yes. So what am I going to get on the screen? I got an A. Okay. Now what if I want to print out the integer value of A?
It's not going to print anything.
Ruh-roh.
Oh, integer? It's going to be 8 still. Unless it's going to do the ASCII numerical value of it.
Helps if I'm in the right block when I run it.
65, you're right.
Huh. Why? Well, inside TextPad, Eclipse might have this, I don't know. But if you do View Clip Library, you can see the ANSI or the ASCII chart. Scroll on down, you'll see A is 65.
I was gonna say, what if you put a lowercase a?
Then it has the
It'd be something
value
else.
of, what,
92, 97? 97. Because A is different. Little a is different. Little a is 97. See that? So what if I did, I want to see the character of 65.
It'll print capital A.
Get the capital A. That's typecasting. So you do need to do that for your homework, by the way. That's why I added that. I think it is here in a minute, but I just want to make sure you knew that. Is everybody okay on this very basic working with strings so far? Okay. String methods. There are so many of them. Okay. Char at is amazing. You're going to use it lots. Okay. It says returns the character in the given string at the specified position. Something very important. Starting with position 0. All right. So this says last character : space animal.char at 2. So what's it going to print? Everybody get W.
Yeah, he's right.
C is 0. 0 is 1. W is 2. Okay? Let's do an example of that. Okay? Let's make me a string. Strong.
Strong.
Okay. We'll say Ken. What am I going to get?
Okay.
Get a K. Could I then take that and actually convert it to an integer? What do you think?
It's gonna be
Now I have the ASCII value of the first letter of my name. I have a K. ASCII value of K. Okay. But what if I want this second letter? What do I put? I want the E. What do I put?
1.
I know starting at 0 is weird. Oops. I don't want to. I want to see the letter. E. It's weird, but that's the way. You're just going to have to remember it always starts at 0. Okay. All right. So everybody got care at. Very, 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 very critical. All right. You guys, we don't have that much left in this chapter. I want to stop here. And we're going to pick up next time. Will that work for everybody? Okay. So I'm stopping on 40. We're going to pick up with the length on the next day. Okay. So we're going to discard that. Stop recording.